Hello guys, welcome back to my YouTube channel. So this is the second and probably the last part to the Docker series. And in this video, we will cover the three major topics, which will be Docker files, how do we publish the images to the Docker Hub, and third and last part would be Docker Compose. I'm not quite sure if I will cover Docker Compose in this video. If the video becomes too lengthy, then I will cover Docker Compose in another video, right? So yeah, and before moving on, I will give a short introduction on Docker again. I know it could be boring, but I genuinely want everyone to be on the same page before we dive deep into the complex part of the lab for Docker. So also, if you want a brief introduction of containers, hypervisors, and want to understand the basic commands of Docker, so I would highly recommend to go watch the first part to the Docker series, and the link will be in the description. So go check it out. Otherwise, you can also skip this part and move on to the lab part directly, where we start from the Docker files. All right, so let's understand the basics of Docker and how does it help us uh, to create image, right? So Docker. So as we discussed in the first part, that Docker has a concept of containers, right? So containers are basically, portable, lightweight, and have an isolated environment, right? And we form containers using Docker itself. So let's say you have a hardware. I will draw it down. So you have a hardware, right? And on top of the hardware you have a software installed. You have a software installed as Docker, which will be used to create multiple containers on our system, right? So each container will run my different applications: app 1, app 2, app 3, app 4, and so on. So each application, such as this is running my mobile app, let's say this is running my web app, and so on and so forth. So we form containers using Docker. That's why we need to install Docker onto our system, right? And in the container we have our application packaged, right? So let's so let's say this is our container, right? This is my container. This is my container. This container has operating system as Linux. It has tools such as you can say MongoDB, Node.js. You can say MongoDB with version 4 and Node.js with version 5, for example. And I created a container of my application in my system, and using this container I will create a image of my container, and we can then share this image of my container to my team members. Like some team members are in the testing team, and then such as there are 4 members, so I shared it to the testing team, and then they will test my application. And inside the container you can see that it is running Linux operating system, right? So now whatever system you're working on, Mac OS or Windows, so it won't be a problem because Linux is installed within the container. It's not installed on our system, right? So containers will run on top of our hardware, right, in whichever system you're using. So such as one team member is working on Windows and one team member is working on Mac OS, so they can run the same container which has Linux operating system without any problem, right? Also you can see that in my container I'm using version 5 of MongoDB and version 4 of Node.js. So this configuration also stays the same, right? So this will stay same when other team members run this container. Hence this saves time as we don't need to set up the environment for each team member separately. Like for example, we don't need to install same version of node.js or mongodb with version 4 onto each team member systems separately, right? So this is the basic concept of Docker. And now let's move on to the practical part. All right, so I'm on my system right now, and I already assume that you guys have Docker Desktop and Visual Code already installed on your systems. And if not, so you can watch the first part of the Docker series, and the link will be in the description. So do install Visual Code and Docker Desktop because we need this in this tutorial. Let's start with Docker files and let's understand how do we create Docker files. So for that, I will create a sample Node.js application. And for that, I have created a folder Docker node in my system and I opened it using Visual Code. So you can also do the same thing and name your folder anything you want. And also let's go to Docker Desktop and let's stop all these containers and images that I have currently, because otherwise I will also get confused and you will also get confused. So for that you can just click on this and delete. So all the images that were pulled before, sorry, all the containers that you will have will be deleted. So it is taking some time. Also you can do the same thing from here. You can see that you have a Docker logo over here. So it will show you all the images or containers that you have available. It will be same as the Docker Desktop. So you can also delete all these from here. So sometimes if Docker Desktop is not responding, so you can just do it from here. So let's wait. All right, so all the containers are finally deleted, and let's also delete all the images, right? So delete forever, and sometimes it takes a lot of time to delete. I mean, it lags a lot sometimes, Docker, right? So you need to wait, or maybe you can restart Docker Desktop and then it will work. All right, so let's create our application for Node.js. And for that, first I will write npm init, because we will initialize this folder, Docker node folder, with the Node.js project. So that's why we write npm init and we click enter. And again, yeah, you can also access the terminal using this Visual Code, so you don't need to open the terminal uh, separately. You can just use the terminal from the Visual Code from here, right? So after you write npm init, so you have to click enter multiple times like I'm doing right now. So this will create a package.json file. Package.json is included within our Docker node folder, and we can also check the contents of package.json. So in this package.json, we got this automatically after we executed the command npm init in the terminal, right? So it will be included automatically. So you don't need to modify this file at all, right? Now let's include npm install express. So basically we need npm install express, because express is a popular web framework for the server side applications in node.js application, right? In the node.js, basically node.js needs express to manage all the routings, all the requests, and the middleware. So that's why it's needed, otherwise our application won't work. Yeah. And now let's include a file called app.js. You can call it app.js, main.js, or index.js. We will create our node.js app in this file app.js. So let's write const express equals to, yeah, um require expresses express, and request x, okay, express, then const app equals to express. Yeah, it would be, I think, yeah, okay, express. Then const port equals to process, yeah, dot env maybe, dot port. Or it will use the default port 3000. So either we will mention the port using the environment variable when we will run our container, or we will use, if we don't mention anything in the as an environment variable, so it will use port 3000 by default. Now let's do the routing. App.get and app.get a request response, and it will be like, I guess, yes, all right, and request response, and then we will send a response when we hit this URL, for example localhost 8080, then we will send a response back, and the response would be response.send. Yes, response.send. Let's say hello, welcome to code with Mars. Welcome to code with Mars. All right, and let's, yeah, all right. Then let's listen. App.listen on the port. App.listen port, um and curly braces. Yes, app.listen port, and then let's print a console.log. Console.log. Let's say local host is running on port. Yeah, local host is running on port. Then we can write like curly braces and then mention the port, so it will print it in the terminal. So here we are including the express module, then creating the express application, then defining the port, creating the route and sending a response back, and then creating the then starting the server and listening on the port specified, and then also printing in the console this message. Now our application is ready, and now let's dockerize our application. So now let's create a Docker file. So make sure you name it like this, because if you do so, then Visual Studio will automatically detect that it's a Docker file, and I have to create an image out of this Docker file for the application. Well, Docker file would contain all the definitions and instructions to create the image of our application. So basically I will write all the commands and the definitions to include app.js, package log.json and package.json into my image. So I will write all the commands so that I can include all my application files into the Docker image, and then we will create an image out of the Docker file. Let's start by including a base image. So for that we write from let's include base image as node with version 14. So always whenever you start writing Docker files, so you would need to include the base image. So basically base image is like a pre-configured environment which contains all the dependencies that your application would need to run. So you don't need to write everything from the scratch, right? So you don't need to install all the dependencies separately. Your node, the node base image that I have written will include all the dependencies that my node application would need by default. So it's already pre-configured, right? So that's why I've included this base image, and this will pull all the dependencies that my application would need from the Docker Hub. So this node image would be pulled from the Docker Hub, including all the dependencies that my application would need. So this is really important, and I don't need to write any extra command now. I can use other images also as base images, but for that I would need to include all the dependencies separately, and then I would need to write a lot of commands, right? And it would waste my time. So I'm just including node directly, so I don't need to install dependencies now separately because they are already included in this base image. This official base image for node will already include a Linux operating system, node.js, npm already installed in this image, so I don't need to install all these packages or dependencies explicitly. Now let's create a working directory within our container or the image. So let's create a folder within our container. Let's name it the same as the folder's name, Docker. Let's do it like Docker node. So we have this folder now inside our container. We are also under this folder within the container. So now let's copy all these files, app.js, package.json, and package log, into our container. So now for that we will write the command copy package.json and then docker node, then keep the file names as same within the container also, it's recommended. Then we will copy package log.json into package log.json. Then let's finally copy app.js. By the way, we don't copy node modules because it will get created automatically when we run the container, so we don't need to include node modules. And yeah, let's make it capital. So always first you have to copy package.json always, because it will include all the dependencies, then it will run the app.js, and make sure that you keep the file names same because it is recommended. After copying all the files, then we will execute, then we will run npm install. So what this will do is that it will include everything that is included in the package.json. So it will include all the dependencies mentioned inside package.json into the container. And second thing it will do is that it will create a node modules folder inside our container. So it does two steps, and it will include all the dependencies that are specific to our applications which are mentioned inside package.json. And second thing that it will include node modules. It will create node modules and include it inside our container. Then we finally write node and app.js. So we finally write this command to run our application inside the container. So all these steps from line 1 to line 15 will execute one by one, right? It will start from this. It will first include the base image, then it will create a folder, then it will copy all the files inside our folder, then it will run npm install and include all the specified dependencies that are in our package.json json, then it will run our application using this command node app.js. So our docker file is now ready, and now let's create an image using this docker file. So for that we execute the command in the terminal, docker build /t, to mention the image name that we want. So maybe I will create an image with the name docker node, maybe let's say image, right, for our understanding. So we will create an image using this docker file. So for that we write docker build slash sorry hyphen d. This is the tag, and this is a tag that we use, and we will then write dot. So this dot means that the docker file is within this directory or within this folder, right? Then press enter. So it will take some while because it has to pull the base image also. So you need to wait for a while. In created, as you can see, after we executed docker build hyphen t docker node image, so our image with the name docker node image has been created. So we can also verify it by executing the command docker images. Okay, so our image has been created. As you can see that it's written docker node image. Let's first clear the terminal, and now let's create the image. Now let's create the container using this image, right? So for that we write the command docker run, and let's give a name to our container. uh, let's say we name it like docker node container, right? It's a bit long, but I think it's much understandable like this. Docker run hyphen name docker node container. We will run it in detached mode because we don't want the logs to be printed, and so that our screen for the terminal is not blocked. And then we will do the port mapping and publish it to the default port 3000. So we use the default port 3000 to our local host port 3000, right? Detach mode published, and let's mention the image name. Yes, finally the docker, our image name was docker, yeah, node, and then image, then enter. Now it will create a running, so it will build and create a running container now for us, and it will map it to localhost 3000. So we can now, after this container runs, we can check it on our web browser. So you can see that my container is running, right? So we can execute docker ps and verify if it's really executing or not. So yeah, it's executing. You can see it from here that it's running on port 3000. And let's execute the localhost. Localhost at port 3000 to verify if it's working on the web browser also. And right, so yeah, look, it's printing hello, welcome to code with Mars, as we mentioned in the app.js over here, right? Let's quickly understand now how to pass the port number as an environment variable when we run the container. So first let's stop the previous container that is running. So for that we write docker stop and the container name, which is docker node container. Let's stop this running container. And then let's create a new container of the same image. but now we will pass the port number also as an environment variable. So for that we will write the command docker run -d. Then for passing the custom port number as an environment variable, we write -e. Then we mention the port that we want to use for the container. So I mentioned port, let's say 8080, right? Now I mentioned default container port as 8080, and now we will publish it and do the port mapping. So I'm matching or using the local, I will be using the localhost port 8080 and will be mapping it to the container port which I just mentioned, 8080, right? This one. So this port, this thing is this, right? And let's mention a container name also. uh, After, let's mention it over here, hyphen name container 2, let's say, right? And write the image name. Let's write the image name now, docker node image. I think everything is correct, so let's press enter. And now the container will get built and it will start running as it printed the ID, and we can access it now on localhost 8080. Alright, so the container is running. Let's check if the container is running on localhost 8080 or not. So for that I wrote localhost 8080, press enter on the browser, and you can see it's again printing the same message. That means it's running on the port 8080 also. Now let's understand how do we build custom images, and also, like, we understood how to build custom images. All right, so now we understood how we create Docker files and how do we create images of our application using the Docker files. So now let's go to the Docker Hub and let's understand how do we publish our images, custom images, to the public or to the private repositories on Docker Hub. So for that, to push our images from locally to the Docker Hub, first let's go to Docker Hub. I'm on the Docker Hub right now, and make sure that you have your free account already created on Docker Hub. And after you are logged in, just go to the repositories and let's create a public repository. So click on create repository. Let's create a repository over here which will be available publicly. So over here I'm creating a public repository. So for that, let's mention a repository name. So for that I will write docker node and let's write it like test image, right? Let's say docker node test image. And you can see that my visibility will be public, so it will be available for the public on Docker Hub, but I can also make it private if I want my image to be accessible within my team only, or within my own organization, or within my company only. So but I'm doing it public because I want it to be available publicly. I don't have any private organization, so I will push it publicly. So click on create. So it will create a image on the Docker Hub, right? And you can see that our image has been created, but this will be our image name, right? So this was our repository name, and this complete is our image name. It will include our ID also, and my ID is mas456. So let's copy this. So this image is available publicly on Docker Hub, and it is not available locally. So that means I need to create an image for my Docker file with the same exact name locally first. Then I will push it to the Docker Hub. So I need to create an image locally with the same exact name for my Docker file. So for that I will create a new image locally. So for that I will write docker build t and give it the same name as I have it on the Docker Hub, and then mention dot that I want to create a image which will be in the same folder in the Docker node, right? So that's why I mentioned the dot, that the Docker file exists in the same folder. So I will create a new image, press enter, and a new image will be created. My image has been created, right, with the same name. And make sure that instead of I just wrote a wrong name, instead of testing I used M instead of N. So yeah, I made that stupid mistake. So the image has been created, and now let's push this image to the Docker Hub, right? So first let's see how many images we have available to verify. So you can see that we have a Docker node image which we created previously, and now this is the new image with my ID. But of course I wrote a wrong name over here. Instead of testing I wrote something as testing. So first let's clear the window, and we will now push this image from locally to the Docker Hub. So for that we write docker push mas 456 slash, using the same image name, and make sure to use the same image name, because otherwise we cannot push it to Docker Hub, because the image name should be same locally and on the Docker Hub, right? Do remember that. I will execute this command, and it will now start to push my image that was created locally to the Docker Hub, and the names are the same, of course. Yeah, so let's wait until it gets pushed, and then we will verify it if it's created or not from the Docker Hub, or if the image is available or not on the Docker Hub. All right, so the image has been pushed, so let's verify it from the Docker Hub. Let's reload it. Let's reload this Docker Hub, and my image has been published onto Docker Hub. You can see that it is written tag latest operating system image, and it is pushed 2 minutes ago. All right, so my image is available now publicly, and now anyone can use it. They just have to write the command docker pull and no mas 456 slash docker hyphen node hyphen testing, or they can, instead of writing docker pull, they can use docker run command, and it will be available on their systems then locally, right? Now we understood about Docker files, how do we push the images to the Docker Hub, and now let's move on to the last part, which is Docker Compose. All right, so let's finally understand about Docker Compose. So let's say if our application has multiple services, right? One service for front end and one service for back end. So for each service we will create a separate container. So back end service would run at a different container, and front end service would run at a different container. So we would need two containers in total. So that's why we use Docker Compose, because if our application has multiple containers, so Docker Compose can be used to create and run those containers at the same time all together, right? So Docker Compose will create multiple containers in our application at the same time all together. So you don't need to create a container for each service separately, by writing separate commands. So you can just write a single command, and using that Docker file, you can create and run all the containers all together, right? Or you can also destroy them altogether. So that's why Docker Compose is useful, and we will learn it now. All right, so the file that will run my multiple containers is called Docker compose.yaml, right? So in this file, I will write all the configuration, which will in this file of I will mention all the services all the containers with their respective port numbers that will be created once I execute a single command of Docker Compose. So it will run all the containers or the services mentioned inside this Docker Compose.yaml file. So let's say I have a node application right now. So let's say this node application of mine is connected with a Redis database, right? So what I will do is I will create a separate container for Redis, and I will create a separate container for my node application. So I will mention it over here that I want a container for node and I want a container for Redis, right? I'm just writing a name. I mean, these are not the actual commands. So I will create a container for Redis. I will create a container for Node. So I will mention all the configuration for both of these services in this Docker compose.yaml file, right? And then these both services will run on different containers, but they will be, of course, be connected using Docker, of course, because this application needs both of the services to run all together, right? So both of these services will run on different containers, but they will be connected, right, using Docker. Otherwise, they will not run, all together within the same application, right? Since they are connected, so they run on different containers, but they are connected using Docker. We will mention about both the containers in the Docker compose.yaml file, and both the containers will start running using this Docker compose.yaml file. And after these containers will start running, right, so they will be also connected. And within this file also I will also mention or assign different port numbers to both of them respectively, as we don't want both of them to run on the same port number, other because these both containers would clash then or interfere with each other. So we don't want that, so we will run both of these commands or both of these containers on different port numbers. It's also very good if you want to test each of the containers separately. That's why also writing separate port numbers or assigning separate port numbers to both of the services is a good choice, right? All right, so let's write our docker compose.yaml file. So first we always write the version of the docker compose file, and usually we write it as 3.8. I don't know what the latest version is, but let's write it as 3.8, right? Then we mention the services. So services basically the containers. So services will include all the containers that are part of our application. So as I mentioned that our application is Node.js, right? So we will include two containers here, Node.js and Redis. So assume that Node.js and Redis are both part of our application, right? And then let's write a container name as node app, right? So node app is one of our container, and it will be created from the it will be built from the current folder, which is docker node. Okay, so it will use the docker file in this directory and will create the image using the docker file. All right, so it will build the image using the docker file that is in this current directory, and it will name our node application as node app. So it will name our container of our node application as node app, and let's assign it a port. um, Port, let's map it to because our node application is running on port 3000 by default, so let's give it 3000 also. So let's do it on 3000, right? So I gave it port 3000, and I think it should be ports. And yeah, there should be a space over here. So port 3000, and let's give another image, another container name as Redis, right? So this is my second container. This is the backend, the database, Redis database. You can assign them any name you want, but I chose these names, but you can assign any names you want. Then tab, hyphen, and let's build it from Docker Hub image, but let's see what is the image for Redis. So let's search Redis. So this is Redis. So let's take this tag Alpine. So pull the Redis image with the tag Alpine from the Docker Hub. So it will, of course, our Redis doesn't exist locally since we didn't create this image locally. So it will pull the Redis image, the official Redis image from the Docker Hub, right? Because it's an open source, it's publicly available. And then let's mention the ports for this. Let's map it to, but I don't know its default port, so I think it should be somewhere. What is the default port for Redis? I think let's let's check it over here. Right, let's check the Redis default port. The default port for Redis is 6379. You can also find it, well, I didn't find it on the Docker Hub, I found it on the Google. So you can just search on Google that what is the port for Redis, default port for Redis, and you can find it. So I'm mapping it to the localhost 6379 to the default port 6379. So this is the default port and this is our localhost port. So yeah, so now let's understand what this file has. So this is the version of the docker compose.yaml file 3.8. These are the services or the containers that we have included. One container that we have is the node app, is has the name node app. The second container that we have has the name Redis. So the first container uses the docker file to create the image and to run the container, and it will run on the port 3000. And the second container for Redis database has the container name Redis, and it will pull the official image of Redis with the tag Alpine from the Docker Hub, and it will make it available locally on our port 6379 on the local host. So now let's um, run this Docker. Let's execute this docker compose.yaml file now. So for that we write the command docker compose up, but with docker composer I will also write -d so that this is executed in detached mode and the logs are not printed in the terminal and it doesn't block my terminal, right, the logs. So what this command will do is so you can press enter. So what this command will do is it will build and create the containers I mentioned here. So it will build the and create node app and the Redis container. So it will build and create both of my containers that I mentioned here. So yeah, I just made a mistake. That's why my docker compose up didn't work. So the mistake was I don't need to mention this hyphen. So just remove it. And one more mistake that I did was, you need to mention this like this. So you need to mention to you need to write the hyphen here. All right, so you need to write it like this. All right, I think it should work now. Let me check. Version, services, node app, build, ports, and over here also. All right, so I think it looks fine. Let's clear and run this command again. But yeah, I think I need to save, but yeah, it will start building. Well, again, it didn't work because I also made a mistake here, because we are not building it locally, but instead of build, it should be image, because we are pulling this image from the Docker up. So that's why it should be called as image. And this is build because we have the image already available locally, right? So now let's try to clear and write the command again. Docker compose up hyphen d, and the now the problem is that the services.redis.ports must be a list. All right, so the indentation was not correct, so I indented the lines properly. So now you can see that I executed the docker compose up hyphen d again. Now it is pulling redis also, and now it is working. So now it's creating the containers, and let's wait until it gets executed completely. Now you can see that our both the containers are up and running. So we executed the command docker ps, and you can see that node app container and the redis alpine container both are running now, right? And this was our previous container, so none of our concern for now. So these were the two containers. So these are the two containers that are up and running now. So let's also try to destroy this docker compose. So let's destroy both of these containers now. So for that we write docker compose. So for that we write docker compose down to destroy them together, right? Since it created both of the containers together, so it will also destroy them together. Our containers have been destroyed now, as you could see. And let's also verify it by executing docker ps, so our containers are not running, and also check if our containers are available or not also. So of course they won't be available, so for that we can check by executing docker psa to see all the containers whether they are stopped or running that were created before, right? So we don't have our docker node and and redis containers available. That means neither were like they were stopped, and also they were destroyed. So yes. Alright guys, so this is the end of the tutorial, and I hope you guys understood all the concepts of Docker Compose and Dockerfile. And if you have any questions, so do ask them in the comment section. And literally I've worked really hard on this tutorial specifically, and I've tried my best, hopefully, to make you understand, to make you guys understand in Docker in the simplest way possible, right? So if I was able to do so, so please make sure to like this video, comment, and drop some love in the comment section, and do subscribe to my channel. So thank you so much, and ciao.